Welcome to Science for Sleep, where wonder and calm meet. Each night we drift through galaxies, oceans, and mysteries of the natural world, not to startle, but to soothe. So, take a deep breath. Let curiosity slow your thoughts, and fall asleep to the sound of discovery. Twilight Zone, where the sun fades with calm authority. Imagine a world not fully lit and not completely dark. A thin oceanic interval where the surface stops declaring meaning and the abyss has not yet claimed the stage. This documentary begins at that gentle threshold. There are no faces here, no hosts standing before cameras, only vast water, ancient physics, and stories carried in drifting bodies and fading light. Down below, between 200 and 1,000 meters, lies the mesopelagic, often called the Twilight Zone, a realm that holds more life than any forest, desert, or tundra above it. It is one of Earth's largest habitats, yet one of the quietest in emotional rhythm, shaped not by storms, but gradients. This introduction is not suspenseful by shock, but engaging by wonder, because scarcity of human presence does not mean scarcity of existence. It means an invitation to explore slowly. The uppermost edge, at 200 meters, still receives light, but light that has already softened itself into mostly blue wavelengths. Red disappears quickly in the ocean, absorbed within the top 10 meters of water. Orange and yellow trail not far behind. Green holds longer, but weakens steadily. Blue penetrates deepest, enduring until roughly 1,000 meters in clear tropical waters, though far less in coastal regions where particles scatter and absorb more rapidly. In the twilight interval, the ocean is illuminated only by suggestion, not clarity. It holds an evening-like consistency that feels inherently less urgent than the surface, yet visually richer than total night. The engagement comes not from loud facts, but scale, from knowing that by volume, this zone contains more than 60% of the ocean's total depth range, occupied by animals that migrate, glow, or drift in synchronized ritual. Pressure increases predictably with depth. At sea level, we live at 1 atmosphere. Every 10 meters downward adds another. At 200 meters, pressure reaches roughly 21 atmospheres, already strong enough to compress air-filled cavities. Yet water itself remains nearly incompressible. Life that dwells here evolved not to resist pressure, but to accept it. Many mesopelagic fish lack gas-filled swim bladders that would collapse as descent continues. Instead, they achieve buoyancy through lipid-rich tissues and reduced skeletal density, bodies that behave like calm hydrodynamic capsules instead of rigid frames. This allows them to hover neutrally, neither sinking dramatically nor rising chaotically. It is one of the reasons this zone translates so naturally into a calming viewing experience despite being biologically dense. Food arrives mostly from above. At the surface, microscopic plankton bloom in cycles driven by sunlight and nutrients. When they die, molt, or are consumed, their fragments aggregate into particles called marine snow. These flakes are not frozen, but soft clumps of organic debris, bits of protein, chitin, silica, fecal pellets, and microscopic shells. They fall slowly, sometimes for hours, sometimes for weeks, lifted gently by currents before settling downward again. This passive delivery system powers an ecosystem not by pursuit, but descent. Many twilight organisms feed opportunistically, conserving energy, waiting for nutrition to drift into contact. Their metabolisms are slower, due partly to colder temperatures, usually ranging between 4 to 8 degrees depending on latitude and depth. a subdued constancy compared to surface waters that fluctuate seasonally. But life does not merely wait. It also rises. Each night, billions of organisms ascend toward the surface to feed under the cover of darkness, then drift back down before morning sunlight reclaims visibility. This is the Diel vertical migration, a global rhythmic event that involves more biomass than any migration on land. Estimates suggest that up to 10 billion tons of animals take part nightly. Lanternfish dominate these movements. Small, silver-bodied, dime-sized to hand-sized fish equipped with photophores, light-producing organs, they move like vertical rivers, pulsing up and down without splash. Sonar once mistook their mass for the seafloor itself. Their collective migration forms a quiet planetary heartbeat, a movement that is efficient rather than frantic. Vision adapts thoughtfully here. Many twilight animals evolve larger eyes with high rod density to detect minimal light, or reflective retinas to gather faint photons. Others evolve counter-illumination, glowing undersides that mimic the faint light from above, rendering their silhouettes invisible to predators below. The ocean here glows not fully bright, but in gentle pinpricks, tiny drifting organisms shimmering briefly when disturbed. It is a star field underwater, functional rather than theatrical. The engagement arises from familiarity disguised as alienness, marine constellations behaving biologically. Sound remains the primary long-distance messenger. Within the mesopelagic lies the SOFAR channel, a depth where sound waves are trapped horizontally due to pressure-temperature density boundaries, allowing low frequencies to travel up to 10,000 kilometers. This acoustic highway is used by whales for long-distance communication. Their songs stretch like slow harmonic signatures across ocean basins. The channel carries sound like a bell carried through water, fading thoughtfully rather than sharply. This zone also hosts delicate drifting hunters, hatchetfish, dragonfish, siphonophores, some stretching 30-40 meters long in chain-like colonial bodies, comb jellies pulsing gently with ciliary lights, and gelatinous drifters that behave like slow-breathing chandeliers in the water column. Many predators here hunt not by brute swimming force, but sensory precision, vibration detection, chemosensory gradients, lateral lines reading pressure wakes, bioelectric fields guiding interception in darkness. The Twilight Ocean also interacts with global climate. This zone is one of Earth's largest carbon processing layers. Each time animals migrate upward to feed and descend to metabolize, they transport carbon from the surface to depth, forming part of the biological carbon pump. This process removes carbon from short-term atmospheric circulation, storing it in deep water currents for decades to millennia. It is a climate function carried out without intentional speed, naturally slow, massively consequential. Human exploration here is minimal by footprint. ROVs, calibrated sonar, sample trawls, and rare submersible dives provide our limited windows. The first humans to reach Challenger Deep descended for 5 hours through a darkness gradient colder than winter and pressures exceeding 1,100 atmospheres. But these visits are rare, rarer than lunar surface walks. Engagement here is awe through minimal intrusion. And the Lantern Dominion, quiet giants of a half-lit kingdom. This documentary now continues into the most numerous vertebrate existence on Earth, the lanternfish. Small, efficient, built like pressure-resistant capsules, their collective biomass forms an unseen architecture of the planet. They occupy almost every ocean, primarily within 300-900 meters of depth. Their bodies are silver, needle-sleek or dime-soft, depending on species, and equipped with glowing photophores arranged in species-specific patterns, used for identification, mating, and camouflage. They do not glow brightly. Brightness is inefficient in a light-scarce economy. They glow faintly, acknowledging communication without demanding attention. Lanternfish perform vertical migration nightly. During daylight, they remain deeper to avoid visual predators. As dusk falls, their biological clocks signal ascent. Upward they move, slowly, collectively, billions of bodies forming silent rivers. Near the surface, they feed on zooplankton. Then, before dawn sharpens the surface again, downward they drift. Without splash, without noise. This migration is the largest mass movement of animals on Earth by biomass. Yet few humans ever see it directly because it happens at night. Sonar imaging once identified their mass as a false seafloor, a mid-water reflective layer. This mistake was not due to chaos, but abundance. But lanternfish are not alone here. Jelly-like drifters accompany them in silent procession. Comb jellies propel themselves by cilia, hair-like structures that shimmer faintly when catching minimal light. Their movement resembles breathing, though they do not need to breathe. Their bodies pulse gently and turn invisibly. Some lack loud bioluminescence and instead refract the tiny ambient blue into soft, rainbow-like flickers along their ciliary combs. It is a functional shimmer, not spectacle. The Twilight Zone hosts strange hunters too, but strange does not mean chaotic. The barrel-eye fish looks upward through a transparent dome of protective tissue that shields its tubular eyes, which are directed toward the faint glimmers above. This adaptation allows it to intercept silhouettes or floating prey against the soft residual blue. It waits calmly, scanning upward, and moves only when sensing contact signatures. This is not frantic hunting. It is energy conservation paired with sensory specialization. The hatchetfish lives by counter-illumination. Its belly glows faintly, using photophores, matching the minimal light from above so that when visual predators look upward, its body blends seamlessly. Its shape is compressed laterally into a small, motion-efficient profile. It does not need speed. It needs invisibility. This makes its drifting existence undramatic, efficient, and adaptable to the twilight economy. Marine snow continues feeding this zone too. Particles clump gently and fall. They nourish passively. This particulate rain forms a slow nutrient ladder, supporting vampire squid, deep shrimp, gelatinous salps, larvaceans encased in mucus-like feeding houses that filter tiny particles, and other drifters that behave like sensory nets, suspended in cold vertical calm. The Twilight Zone also supports creatures that metabolize uniquely for rarity. The vampire squid does not sprint to hunt. Instead, it deploys filament-like arms to capture falling organic debris or small drifting organisms. When threatened, it does not escape by fast swimming. It inverts its cloak-like webbing around itself into a protective shape, shielding gently like an umbrella closing in slow motion. Crustaceans drift like moving stardust. Some emit bioluminescent anti-predator secretions called bioluminescent clouds. Not explosive ink-like defensiveness, but defensive illumination that confuses directionality rather than declaring distress. Even defense translates into quiet light storytelling in this zone. This zone shapes carbon like memory. When animals eat near the surface and descend to metabolize, they transport carbon into deeper circulation, contributing to the biological carbon pump. Carbon is processed and carried downward like breathing time, storing it far from short-term atmospheric cycles for decades to millennia. Even geology does not jolt here. While hydrothermal vents erupt structure below this zone, the twilight interval itself is calm by gradient. The sea does not shout its existence, it suggests it. Bodies of soft design, formed by light that almost arrives. At the twilight depth, life carries an architecture built by gradients rather than edges. Between 200 and 1,000 meters, forms evolve not for display, but endurance, efficiency, balance, and presence without disturbance. In shallow waters, buoyancy is negotiated through swim bladders, gas-filled organs that act like internal balloons. But at mesopelagic pressure, gas behaves chaotically. It compresses, expands, destabilizes, or collapses entirely. Evolution solves this without confrontation, by removal. Most mesopelagic fish either evolve vastly reduced swim bladders or abandon them completely. Instead, buoyancy becomes a neutral trait, earned through lipids, gel-like tissues, small skeletons, and flexible structural design. Lipids do not compress easily, and they provide persistent lift. Many fish deposit oils within tissues, creating a quiet internal flotation system that does not collapse as depth changes. Their bones become lighter rather than thicker. Cartilage becomes common because it is flexible, pressure-tolerant, metabolically cheaper, and structurally calmer than rigid bone. The result is a body built like a slow-response vessel, stable in movement, neutral in float, quiet in descent. Schooling behavior continues at depth but changes its rhythm. Near the surface, fish school rapidly to avoid predators and optimize oxygen and feeding paths. In the mesopelagic, schools do not fling themselves in frantic coordination. They rise and fall collectively like tidal breathing. Lanternfish form the most dominant schools here, but there are others too. Pearl-side fish, bristlemouths, also abundant. Myctophids, lantern family, and drifting shoals of mesopelagic juveniles from surface species that descend temporarily as part of their life cycle. These schools often aggregate loosely during the day and compress slightly at night to migrate upward. Their gatherings form sonar-detectable layers so dense that early acoustic surveys misread them as the ocean floor. The error was not from confusion of noise, but confusion of abundance. The Twilight Zone is a world where visibility does not govern identity. Light arrives only faintly, and so bodies evolve surfaces that cooperate with minimal illumination. Many animals adopt mirror silver or ultra-black skin. The silver is not decorative, but reflective camouflage, bouncing scarce ambient blue sideways so that from most angles, the body decomposes into background suggestion. Ultra-black integuments absorb over 99.5% of incoming light, making the body appear as absence rather than silhouette. Some creatures evolve translucent or semi-transparent tissues, appearing like suggestions moving through a glass of deep ocean. Eyes evolve thoughtfully here. Many mesopelagic creatures possess tubular or telescopic vision, upward biased, because residual light always comes from above. The barrel-eye fish embodies this perfectly. Its head forms a transparent dome that shields its upward-facing tubular eyes. These eyes collect faint photons from above to detect silhouettes of drifting prey or organisms crossing the minimal blue threshold. Its retina is extremely rod-dense, optimized for low-light detection. It does not track speed, it tracks contrast. The dome protects its delicate optical sensors from both pressure and particulate collision against falling marine snow. Particles become landscape in the twilight. The zone continually intercepts falling debris from above, forming a slow rain of nutrients and biological fragments. Unlike surface zooplankton blooms that are cyclical and explosive by reproduction, marine snow is constant, slow, and universal. It does not descend uniformly. It drifts in eddies, rises briefly on gentle currents, spirals like cosmic dust being lifted before settling again. This particulate rain is eaten by slow drifters like larvaceans, who encase themselves in mucus houses, balloon-like feeding nets they build and discard repeatedly. These feeding structures filter marine snow and micro-zooplankton passively, and when clogged, the larvacean slips out and lets the entire house sink without struggle, building a new one in calm arithmetic of survival. This continuous shedding contributes further to the carbon flux of the zone. Predation is sensory rather than chaotic. Many twilight hunters detect motion not visually, but through pressure wakes, chemical gradients, bioelectric fields, vibration signatures, and trail-based sensing rather than active chase. The DL migration clock protects twilight predators from energy chaos too. They intercept migrating prey when biomass crosses through their sensory thresholds instead of powering fast pursuit engines. Even reproduction does not spike here. It signals. Bioluminescent patterns on bodies often act as mating identifiers. Light pulses are short, soft, and coded. Some twilight species produce blue-shifted bioluminescence because blue wavelengths travel farther in water. Most organisms glow in wavelengths between 440 and 495 nanometers. Triangular flashes identify species instead of startling viewers. The glimmer is not theatrical, but communicative grammar of light. This zone supports animals by endurance, drift, and rhythmic migration, not oxygen panic. Light fading downward is not tragedy. It is prompt. The ocean here holds calm metabolic signatures, slow sensory reading systems, pressure-tolerant anatomies, particulate feeding webs, rhythmic migrations, neutral buoyancy vessels, mirror and black light cooperating surfaces, translucent designs, upward biased tubular eyes, and coded blue bioluminescent communication that unspools gently through immense volume. The largest migration with no splash. The mesopelagic is best understood not in stillness, but in motion. A cyclical, vertical motion that resembles the calmest possible definition of travel. Each evening, when surface predators return to slower night metabolisms and light loses its sharp angles, one of Earth's most immense biological events begins. The DL vertical migration. This is a movement of staggering biomass. More than 10 billion metric tons of life collectively drifting upward toward the surface to feed. Then returning downward before dawn restores visual predation advantage to shallow hunters. The migration does not roar, it drifts. It is not conquest or escape. It is ritual and survival timetable fused by evolution into choreography of inherited clocks. These animals migrate for food, for directional safety, for reproductive signaling, and for carbon transport as part of Earth's most ancient biogeochemical pump. The migration ladder is built from layers. Zooplankton and small midwater crustaceans rise toward microphytoplankton layers and surface detritus to feed. Microscopic larvae from surface species drift temporarily upward, using genetic timers to know when to return. Jelly bodies rise too, but not chaotically. Propelled by slow pulsation or cilia shimmering like faint parabolic lights. Predators position themselves not by flared aggression, but by sensory interception. Lateral lines reading pressure wakes of the migration corridors. Chemical gradient hunters detect trails of rising crustaceans, or larval bodies, by fingerprints of dissolution in water. Lanternfish remain the principal migratory vertebrates. Myctophids, their bodies small, capsule-efficient, lined with photophores arranged in precise patterns that do not flare unpredictably. Each flash is short, controlled, nearly punctuation, rather than sentence, coded instead of expressed. Their upward migration is one of planet Earth's most predictable daily cycles. Coupling pressure-compatible tissues with lipid-rich buoyancy, they ascend in soft vertical rivers. Some remain near 300 to 500 meters. Others push upward closer to 200 meters, depending on clarity of the water and predator presence. The migration is thicker in the open ocean and less dense near coasts where turbidity scatters light more quickly. Before dawn, the migration reverses, with a collective downward drift into deep resting metabolisms. The return is not escape, it is timetable completion. The night economy ends and the twilight economy resumes its deeper blueprint. This backward migration contributes profoundly to carbon flux, transporting surface carbon into deeper storage as animals metabolize food at depth, where carbon is exhaled into deeper chemistry of water for decades to millennia before resurfacing through thermohaline circulation corridors. The oceans do not evenly feed this zone, they seed it. Surface productivity constantly produces particulate fragments, and gravity delivers them thoughtfully downward. But migration animals do not compete for marine snow exclusively. They rise to feed more actively on zooplankton and small crustaceans near the surface, which contain more abundant particulate nutrition compared to the twilight's passive fall. Though this migration is immense, it is nearly invisible to surface humans without scientific instruments. It was only detected when sonar pulses returned unexpected reflective layers far above the sea floor. The mistake was discovery. The mass was mistaken for geological floor until careful sampling revealed the truth. Billions of fish bodies forming a false acoustic seabed. The zone also contains species that do not migrate, but hover opportunistically. Some squid maintain slow, neutrally buoyant drift positions. Others, like bathypelagic siphonophores, stretch long colonial chain bodies that are not entirely within the 2,000 meters requirement, but drift upward into twilight corridors at night when food corridors are richer. Predation here is stillness, tuned to interception. Many migrators avoid being eaten not by speed, but counter-illumination. Hatchetfish glow faintly on bellies to match light above. Predators positioned below see only dissolved blue, silhouettes hidden by mimic light webs. This is camouflage by cooperation, not chaos. The twilight sea also supports creatures built to chemically metabolize rarity. Bristlemouths, cyclothone, small dime-sized fish that may not always migrate, but form the deepest biomass measurements in marine biology. Their bodies are extremely pressure-tolerant, minimal skeleton, lipid-fused vessels tuned for endurance rather than aggression. Despite their abundance, little emotional drama surrounds them. They exist quietly in census-breaking numbers without display. This migration is one of planet Earth's quietest pulses of immensity, unspooling upward and downward daily, like synchronized metronomes operating in vertical blue. The zone is not empty at day, it is compressed slightly. It is not chaotic at night, it rises collectively. It is motion as inherited timetable, biomass as vertical rivers, reproduction as short-coded glimmers, feeding by ascension, defense by mimic light, carbon pumping by descent, and survival by rhythm. The twilight is not a place of suspense. It is a place of schedule. Silent sensors and the art of reading water. The twilight ocean rewards organisms that read the environment rather than declare themselves into it. Life here survives not by speed or visual dominance, but through sensory refinement that works with calm precision, shaped by light scarcity, distance, and evolutionary economy. Many animals rely on the lateral line system, a sensory network of fluid-filled canals running along the bodies of fish, detecting minute pressure disturbances created by nearby movement. It does not perceive sound dramatically, like a loud conversation, but more like a quiet fingerprint left by motion in water. Fish here can sense the ripple wake of another organism passing meters away without needing to see it. This system detects vibration frequency, movement amplitude, directional pressure gradients, and acceleration fields. Lanternfish use lateral lines to coordinate schooling migrations without colliding in the blue minimal visibility. Predators use it to intercept prey migration corridors by reading pressure wakes instead of chasing rapidly. It is an underwater language of touch without contact, reading motion remotely, like faint handwriting being traced rather than spoken aloud. Chemosensation joins this quiet sensory suite. Molecules drift differently underwater than in air. A chemical trail left by a migrating copepod or drifting larvacean dissolves into gradients rather than thin lines. Sensitive mesopelagic fish and squid detect these trails via receptor-rich olfactory pits or distributed chemoreceptive cells along soft tissues. Predation thus becomes not a chase, but calibrated detection. The animal waits, senses a concentration gradient of amino acids or trace metabolic molecules, then moves only enough to intercept the source. No strike is wasted. No motion is panicked. Precision replaces urgency. Some animals still retain vision, but vision tuned for contrast, upward bias, and light capture efficiency rather than resolution. The barrel eye fish is emblematic. A transparent cranial dome shields its tubular eyes, allowing them to collect every faint photon that arrives from above. These eyes are pointed upward permanently, tracking silhouettes or dim flashes against the residual blue gradient. Rather than moving quickly, barrel eyes hover in near effortless buoyancy, scanning thoughtfully. Prey detection is thus binary by contrast, not complex by detail. Shadow or light, presence or absence, motion or stillness. Detected without emotional spike. It is visually engaging to the awake mind, but metabolically calm for the organism. Bioluminescence here follows utility grammar. In a world where light almost does not arrive, organisms manufacture small amounts of their own, not for spectacle but identification, mating punctuation, defensive direction confusion, and camouflage. Counter-illumination is most common. Many mesopelagic fish possess photophores along their bellies, emitting blue shifted light between 440 to 495 nm to match light from above. This hides their body silhouettes from predators below that view upward. The glow is soft and matched, not sudden or intense, a quiet homage to the limited light budget of the zone. For mating, flashes are short and coded by species. Timed light packets rather than loud billboards. Enough to signal location or identity, never enough to overwhelm the dark. Defensive luminescent secretions sometimes bloom from small crustaceans like copepods or ostracods, forming faint blue clouds when disturbed, confusing predator strike direction without panic. Even the prey animals embody calm economy. Copepods, small crustaceans only millimeters long, form enormous populations that rise each night into twilight columns to feed on surface phytoplankton or near-surface zooplankton layers. Despite their vast numbers, individual motion is tiny, hydrodynamically efficient, and pressure-tolerant. Their bodies are small, requiring minimal metabolic fuel. The ocean does not feel crowded here because space between organisms can still be kilometers wide despite the colossal biomass involved in vertical migration. Immensity is achieved by number, not noise. Many mesopelagic animals also practice metabolic patience. Food is available, but not continuously abundant. Animals alternate between small feeding windows near the surface and long periods of low-energy existence at depth. Their physiology supports slower metabolisms, reduced unnecessary movement, and opportunistic feeding rather than regular grazing. It is a constant negotiation with pressure-temperature arithmetic. This balance maintains not drama, but sustainability. Survival is thus a poem of minimal motion, calibrated senses, utility glimmers, neutral buoyant adaptations, and evolutionary tail-designed reading systems that detect the ocean without disrupting it. The ocean itself seems to approve these adaptations. Because sound travels farther than light in these depths, many species use soft acoustic clicks, low-frequency pulses, or pressure signaling to interact rather than visual cues. The twilight is not silent because it lacks communication. It is silent because communication is tuned to distance, endurance, and minimal waste. The ocean writes faint stories along sensory networks older than continents. Currents that carry rather than collide. The Twilight Zone is crossed constantly by a system far larger than any organism, the slow architecture of ocean circulation. At these depths, currents are not chaotic or turbulent by storm energy. They are the long, deliberate outcome of thermodynamics, salinity differences, pressure density gradients, and planetary rotation forces that unspool quietly into motion. The biggest of these systems is thermohaline circulation, a global conveyor belt driven by water density differences influenced by temperature and salinity. Cold, saline water formed near polar regions becomes dense enough to sink. This descending water forms deep currents that move slowly across basins before resurfacing centuries later. The migration pace is glacial by time scale, kilometers per hour instead of meters per second, yet spans the world in massive, slow loops. This system protects the weekend and season from arriving at flash cadence. It also carries heat, oxygen, carbon, and nutrients in distributed chemistry rather than concentrated collisions. Beneath this gentle conveyor also lie internal waves. Unlike surface waves formed by wind, internal waves begin underwater, generated by tidal pull, seafloor topography disruptions, or pressure gradient shifts between water layers of differing density. These waves can be taller than skyscrapers, some rising 100 to 200 meters high, but their motion is not loud splashing. It is layer to layer rising and falling, like slow pulse heaves that move energy upward without breaking the surface. These waves guide plankton and drifting organisms into feeding corridors without turbulence panic. They behave like calm, underwater breathing mountains, shifting thoughtfully. Currents sometimes cross into the Twilight Zone, carrying oxygen-rich or carbon-dense water plumes. But these plumes dissipate into gradients rather than creating violent interfaces. Many mesopelagic animals exploit these density boundaries for migration corridors or predator avoidance. But interface here does not mean collision and violence. It means gradient transition without shock. The biology of this zone depends not on sudden nutrient upwellings, but planetary rarity distributed by slow drift. Even chemistry moves calmly here. When particles sink or animals metabolize food at depth, they exhale carbon dioxide, ammonia, and trace metabolic byproducts into the water. But unlike land atmospheres where gas forms concentrated plumes, underwater gases dissolve into chemical gradients that are sensed by other organisms but rarely noticed as intensity. Nothing spikes. Everything dissolves into background calm. The Twilight Ocean hosts some of the largest animal biomass movements on Earth. Yet it remains quiet because scale does not equate to noise here. Immensity emerges not as a roar, but census-breaking number drift. vertical breathing migration choreography, global density-driven conveyor belts, and internal waves traveling layer corridors, without surface drama. It is an ecosystem built not for shock, but equilibrium, efficiency, scale through replication, and the calm arithmetic of planetary ocean physics. While continents above experience storms, droughts, wind noise, predation chase spikes, and visual chaos, the mesopelagic twilight remains emotionally stable. Identity exists through trace-light glimmers, pressure wake readings, chemical gradient sensing, rotational Coriolis-influenced currents drifting across hemispheres, zero sound signature migrations below night cover, and deep thermodynamic loops distributing planetary constants across decades and centuries. This makes the network engaging to learn about, yet calming to consume, because excitement is concept, not cadence, and motion is ritual, not panic. This corridor between the surface and the true abyss quietly regulates Earth's climate memory too. The vertical migration of animals contributes to the biological carbon pump, transporting surface phytoplankton-derived carbon into deeper chemistry layers, where it stays removed from rapid atmospheric exchange for long periods, joining the slow thermohaline cycle. This is not intentional sequestration. It is nature's unhurried flux. The blue light economy and the quiet architecture of feeding. The documentary's journey now moves into the calm mechanics of how energy enters this depth, how hunger is shaped here, and how creatures survive by patience, vertical travel, and the soft particulate gifts that descend from the world above. In the mesopelagic, sunlight is present only as fading suggestion, not as plentiful fuel for photosynthesis. Green plants, forests, and surface phytoplankton above form the ocean's primary producers, capturing solar energy and converting it into biomass. But here, between 200 and 1,000 meters, life feeds not on the sun itself, but on its leftovers, delivered slowly through oceanic inheritance systems rather than rapid supply chains. Each day, fragments of surface productivity sink into deeper layers. These particles are known collectively as marine snow, small clumps of organic detritus composed of dead or dying phytoplankton, microscopic shells, fish fecal pellets, silica fragments, protein aggregates, chitin, bacteria-bound clusters, and micro shards of life's aftermotion. They fall softly, sometimes taking hours, sometimes weeks, swirling on intermediate currents before settling downward again. This particulate rain acts like a gentle nutrient elevator, feeding suspended mid-water organisms without seasonal spikes. Some animals feed by migrating upward instead of waiting. Zooplankton species, including copepods, krill, amphipods, larval crustaceans, catechnaths, arrowworms, micro-jelly larvae, and tiny migrating siphonophores rise each night toward the near-surface layer to graze on plankton-rich waters under darkness cover, then return before dawn. The migration itself does not startle the ocean. It is timed, slow, and predictable. This migration brings massive biomass into feeding contact, but its style remains calm. Small motions multiplied by billions. Lanternfish often swim upward roughly 200-400 meters at night to intercept denser feeding columns, grazing quietly on surface zooplankton or near-surface plankton blooms. Others stay deeper around 600-900 meters, depending on predator presence and water clarity. The ocean does not grow warmer and brighter at night, but it offers invisibility. The quiet engagement comes from scale, biology, and evolutionary sequencing rather than excitement pacing. Larvaceans represent a key part of this feeding structure. They create mucus-based balloon-like filtration houses, sometimes up to a meter wide, drifting passively while trapping tiny sinking particles, micro-zooplankton and organic snow. Once clogged, the larvacean slips out calmly and creates a new house, while the old one sinks downward without frantic disruption. This continuous shedding also contributes to particulate carbon transport, constantly drifting deeper as part of the biological pump. Larger species like krill and small juvenile squids rise too, feeding subtly, appearing mostly as dark silhouettes flickering occasionally in residual blue minimal light. Some species rely more on filtration and chemical interception feeding, reading the ocean's chemical drift gradient for amino acids rather than visual food abundance. This zone supports both passive feeding from marine snow and active feeding without rapid motion via nightly migration corridors. More than 90% of oceanic food production starts in surface 50 meters. But much of the biomass feeding below is delivered through unhurried sinking cycles or timed vertical ascension, not by violent upwelling collisions. The ocean feeds twilight organisms like a slow respiratory inheritance, not a sprinted economy. In this realm, hunger is shaped by metabolic patience. Cold temperatures and scarcity of oxygen-rich return pathways encourage reduced movement, energy conservation, and opportunistic feeding windows instead of constant grazing. Deep biomass does not mean crowded sound. It means quiet physics of replication. Even microbes contribute thoughtfully. As bacteria colonize sinking fragments, they bind particles into small clumps, adding to the marine snow size and density, allowing them to fall consistently instead of diffusing instantly. These microbial interactions form a gradient ladder, sustaining mid-water hunger grammar. Predators of the half-lit kingdom, hunters that move only when necessary. The documentary now drifts into another side of the twilight interval, predation, a process that remains efficient, sensory-driven, and low-emotion cadence compatible with calm viewing. In the mesopelagic, predators do not engage in fast, wasteful pursuit. Instead, they hunt through interception, sensory fingerprint reading, and minimal motion precision because metabolic fuel is precious, pressure is constant, temperatures are cold stable, and visibility is suggestion blue. One of the most iconic hunters here is the dragonfish. It carries a long, thin body shaped like a motion-efficient capsule, lined with bioluminescent organs, but never glowing brightly unless signaling. It dangles a faint, soft glow lure from its chin or forehead to attract tiny prey in darkness without demanding viewer shock reactions. Its eye-like sensors are highly rod-dense, optimized for minimal light capture rather than scenic vision. Some species also possess suborbital photophores that emit directional illumination downward, helping to silhouette prey above without flooding the zone in bright spikes. The hatchetfish hunts by cooperation with what little light exists. It glows faintly along its belly using photophores that emit blue wavelengths closely matching surface residual night glow. This allows it to become invisible to predators below, and also to position itself undetected for interceptive hunting. Hatchetfish silhouette compression makes it a micro-predation, not macro-drama existence. For documentaries, this means visually engaging biological intrigue witut pace spikes. Barrel eyes hunt upward, not forward. Their long tubular eyes, shielded by a transparent head dome, collect fading blue photons and detect silhouettes crossing marine snow plumes or drifting microschools. They hover in neutral buoyancy currents and move only when pressure wakes or contrast shadows pass overhead. Mid-water squids are present here too, but rarely sprinting. They drift as silhouettes, sensing vibration fingerprints in water, then intercept feeding animals that travel upward at night. Their bodies and arms are tuned to slow filament capture rather than aggression chase scenes. Mesopelagic squid predation is lazy by cadence, not by killing efficiency. Extremely fast when it happens, but rare, short, and never repetitive melodrama. The documentaries should show that rare strikes are efficient, sensory-triggered, non-urgent by pacing, and chemistry dissolving in outcome, not explosion. Small crustacean predators hunt by pressure field detection. Copepods remain primary prey, but some predatory copepod species also exist, intercepting even smaller drifting larvae or micro-zooplankton. They may release soft bioluminescent clouds when startled to confuse predator direction or signal distress mates, but these flashes are short and coded. It confuses direction, not the viewer's calm. The deep sea also hosts predators that use chemical gradient maps instead of visuals. Arrow worms detect movement through water displacement gradients. Amphipods scavenge or intercept drifting organic matter, and occasional larvae by chemosensory pits. They rarely compete violently. They intercept quietly. Many predators here adopt ultra-black or mirror silver skin. Black absorbs faint light to eliminate silhouettes. Silver reflects scarce ambient illumination sideways to dissolve identity into the water column. This offers documentaries a visual mood that's intrigue blue, calm black, fact-grounded, unhurried swirl of existence. Predation cycles are also timed by night rhythm, not alarm pacing. The zone becomes a timed feeding corridor for hunter interception, maximizing metabolic gain without shark sprint sequences or dramatic orchestras. No apex predator rules here by size chase scenes. Apex predation is ruled here by nighttime invisibility, sensory field arithmetic, chemical gradient maps, vibration interception, bioluminescent punctuation signaling, and minimal motion hunting, not long suspenseful sequences. The viewer learns that in the Twilight Zone, hunting does not happen in energy-wasteful frenzy, and ecosystems do not use shock timing narratives. Animals hunt like a timed schedule, efficient when triggered, but rarely by repetition. This tone is engaging because it's true. Low urgency by pacing, high consequences by metabolic efficiency, calm for the ears and informative for the mind. The mesopelagic holds a truth that is easier felt than pictured directly. It contains more living biomass than almost any other single habitat on Earth. This does not manifest as audible congestion, because congestion in documentary language is a tempo decision, not a population metric. In ecological census estimates, fish belonging to the myctophid family, commonly known as lanternfish, number in the many trillions, forming one of the most abundant vertebrate populations on the planet. Bristlemouths of the genus Cyclothone, though often deeper, also spill upward into this zone, quietly dominating global counts by virtue of small body size multiplied across immense populations. Together, these species form a mid-water band of life densest, not to the ear, but to the instrument. When oceanographers first studied these depths with sonar, the readings sent back a continuous horizontal reflective layer, one that deceptively resembled the seafloor rising toward the surface. The repetition of echoes had none of the jagged chaos signature of rock or ridge. It had uniformity. For a period, this phenomenon was catalogued simply as the deep scattering layer. Later, careful net sampling revealed the cause. Not a geological shelf, but a vast, living acoustic mirror built of bodies. Although this layer participates in the largest migration on Earth, there is no single powerful organism driving that movement. The migration itself is a function of scarcity economy, predator-prey timing equilibrium, and ancient circadian rhythms. But biomass density does not mean noise density. When trillions of lanternfish move, they move in tiny increments of motion. Each fish only a few centimeters long. Each pressure wake small enough to dissipate quietly. The ocean does not detect them as turbulence. It detects them as quantity. From an auditory perspective, a person listening at these depths would hear little more than faint ambient crackles, distant whale notes, and the low oceanic hum shaped by pressure. But from a heat map of life, this zone is a glowing manuscript margin of existence. The meaning of crowded is redefined here optically. By resolution, it looks empty. By number, it is full. Organic particles falling from above constantly seed this zone, maintaining a baseline food ladder, ensuring that, although hunting is opportunistic, survival is possible at low motion budgets. Larvaceans contribute significantly to this biomass architecture as well. Not by body weight, but by building and shedding filtration houses of mucus that intermittently capture particulate nutrition. These houses, sometimes a meter wide, sink calmly after clogging, constantly transferring carbon, micronutrients, and structural material downward without struggle. Other key contributors to biomass here include gelatinous salps, drifting hydrozoan colonies, faint bioluminescent plankton, amphipods, krill that occasionally pass through this zone's upper boundaries, larval fish from surface species that occupy the mesopelagic only as transition stage, and microbial communities consuming particulate clusters. The biomass of this zone is less a crowd and more a constellation. Sparse optically, abundant numerically, distributed energetically, quiet behaviorally. And so, the documentary perspective holds a quiet engagement by revealing this contradiction, that emptiness and fullness can occupy the same coordinates depending on the sensory lens applied. The biological carbon pump functions powerfully here too. When billions of fish eat upper zone plankton and descend to metabolize, they quietly transport digested carbon into deeper storage layers, assisting Earth's natural climate regulation grammar. The zone's role in global carbon transport outweighs its role in audible or visual spectacle. Predator-prey biomass dance is timetable, not terror. Lightning-fast feeding strikes exist, but rarely repeat, turning predation into short, efficient brushstroke moments in the story, not loud rhythmic jumps. Many animals exist in states of metabolic patience, feeding when corridors pass by rather than grazing constantly. This minimal motion philosophy makes the zone emotionally restful to watch, while conceptually consequential to understand. Marine biologists now estimate that creatures collectively moving through this zone transport immense amounts of carbon, energy, protein matter, and ecological consequence quietly into the depths without creating dramatic spike cadence. Biomass lives here like census, not orchestra. The twilight does not shout with animal movement. It whispers with consequences. Light that doesn't reach as clarity, but still reaches as influence. Light governs behavior long after it stops providing photography. In the mesopelagic, the ocean retains a memory of sunlight, not as direct illumination, but biochemical influence, migration timing, pigment selection, silhouette control, and predator strategy. Red wavelengths are completely absorbed in the first few meters of seawater. Orange and yellow dissolve not far below, but blue endures with gentle authority, penetrating hundreds of meters into open waters, informing biology without exciting it. Because of this, nearly every visual adaptation in this zone cooperates with blue. Proteins and photoreceptors in animal eyes are tuned to detect blue wavelengths between 440 and 495 nanometers. the same wavelengths most commonly produced internally as bioluminescence by twilight organisms. Many animals here don't need to see entire scenes, only silhouettes, glimmers, and pressure-informed contrast against a blank manuscript of diminishing gradient. The most elegant adaptation to this fading light is counter-illumination camouflage. Hatchetfish, pearl sides, juvenile squids, and many species of lanternfish possess photophores along their bellies, emitting soft blue bioluminescent light to mimic the faint ambient glow arriving from above. When predators below look upward, the glowing belly dissolves the animal's silhouette almost completely, rendering it invisible by cooperation, not absence. This is camouflage without confrontation. The glow is not bright, flashing, irregular, or dramatic. It is matched, soft, predictable, and biologically coded, like wearing the night rather than fighting it. For documentaries, this creates a viewing mood that is intriguing by fact narrative, but smells of calm energy pacing. Some species evolve enormous eyes to capture every remaining photon, but not for clarity. The eyes of giant twilight predators like the long-fin dragonfish possess hyper-dense rods for photon capture efficiency, not scenic resolution. The barrel-eye fish builds this even more precisely. Its upward-facing tubular eyes are shielded by a transparent, pressure-tolerant dome of protective tissue that functions like glass armor, protecting delicate sensors. It looks permanently upward, because upward is the only direction light ever arrives at trace levels in the twilight. It does not scan rapidly. It scans persistently. Clarity is method, not cadence. The Twilight Zone also influences the ocean's chemical color palette. Because visibility is minimal, ornamental pigments are unnecessary. Many animals are silver, black, or translucent. These are camouflage strategies for scarce light budgets. Ultra-black skin absorbs up to 99.5% of all faint light, eliminating contrast outlines. Mirror silver scales reflect sideways. Gelatinous translucence dissolves shape entirely. These palettes are engaging to learn, but calm to view. There is no jarring chromatic violence here. Even predators like squid drift in dark silhouettes instead of bursting light scenes. Light influences reproduction too. Surface species declare mating through size, color, motion, or vocal display. Mesopelagic organisms punctuate mating through coded light timing. The flashes are short and never rapid, not fireworks but punctuation, emitted only enough to allow species identification, mate location, or biological grammar of timing. Blue flashes identify myctophid species. Low-intensity light pulses write identity packets. Cryptic signals travel farther than the glowing bodies themselves. The zone's hunger structure remains balanced by scarcity economics rather than seasonal spikes. Food is rare enough to prevent metabolic panic, abundant enough through nightly migration and marine snow descent to sustain life quietly. There is also the timing of the migration. The evening does not trigger feeding by fear. It triggers feeding by ritual. When light dims at the surface, twilight animals know they may ascend safely to feed. When dawn brightens above, they know they must descend again. The ocean writes a soft schedule instead of a suspense alarm, built from inherited biological clocks. To viewers, this zone rewards a documentary pacing that stays balanced, engaging by pure informative conceptual wonder, calm by delivery cadence. Understanding that light influences biology without reaching as clarity shows that deep-sea storytelling can remain energizing conceptually, but calm by narrative motion. The twilight is thus a storybook of influence, not illumination. Suggestion blue, not scenic daylight. Survival by cooperation, not confrontation. predation by interception, not chase, and reproduction by coding, not spike cadence. Foreign starlight, bioluminescent communication without alarm. In the mesopelagic, light is not a stage prop, it is a communication method, manufactured sparingly and expressed quietly. Animals that evolve here do not illuminate surroundings like searchlights crossing scenery. They emit small light fragments, coded, brief, and efficient, sustenance-minded, luminescent packets designed to declare identity, mislead direction, attract feeding opportunity, or locate reproduction partners without escalating into unpredictable flashing narratives. Unlike fire's flicker in forests or lightning's drama in skies, light at depth behaves like grammar. Tiny punctuation written in wavelengths the water allows. Most bioluminescent organisms here emit light between 440 and 495 nanometers, a spectral blue tuned to oceanophysical corridors, because blue wavelengths scatter least, travel farthest, and cost least energy to produce metabolically. This allows a creature's message to traverse long distances without illuminating the entire scene or eroding calm gradients. Lanternfish bodies dominate this twilight census. Their photophores form precise maps, constellations along bodies, species-specific light layouts that work like internal passports. Some fish emit flank-based dotted sequences that identify species to other lanternfish nearby. Others emit soft belly-based glow for silhouette camouflage against faint ambient light arriving from above. Dragonfish produce directional low-intensity underlights that help silhouette prey above them without creating bright environment boundaries that induce alarm. Certain copepods and ostracods release luminescent secretions when disturbed, forming small clouds of light that confuse predator targeting direction without signifying panic. These glimmers are efficient binary functions. Faint cloud bloom, then taper dissolution. Light does not repeat rapidly. It appears briefly and attenuates into background watercolor darkness. Reproduction signals behave similarly. Mating is not declared by ornamental size or chromatic flares. It is broadcast through timed bioluminescent blinking. Light pulses spaced calmly, coded carefully, and rarely repetitive. Enough to locate a partner, but never enough to rouse the entire zone or induce obsessional curiosity loops. The Twilight Zone is not about who glows brightest, but who glows accurately enough for species recognition. Even microbial colonies sometimes contribute minute luminescent flamelets while consuming decomposing particulate snow. But their microlight never floods the zone. This soft light economy is part of why mesopelagic documentaries find a natural balance between engagement and calm. Light at depth writes existence like gentle Morse code, short, informative flashes, long pauses, immense consequence through replication rather than drama through intensity. Whether it's a hatchetfish glowing its belly invisibly, or a lanternfish school moving in gravity's silent elevator, or a copepod secreting luminous clouds when disturbed, light in this zone serves meaning without urgency. The viewer learns not through spikes, but scale. It is an ecosystem where brief illumination meets massive presence. Below this zone, darkness begins totally. Above this zone, light is sharp but limited to a thin atmospheric layer. But here, in between, light informs life processes calmly. This depth is proof that illumination is not required for storytelling. Suggestion is enough. Sensing is stronger than seeing. Identity is coded instead of declared loudly, and engagement arises from scale rather than shock. Chemical maps, slow hunger, and the art of intercepting gifts. Hunger in the Twilight Sea does not behave like hunger in sunlit zones. It does not scream scarcity, and it does not celebrate abundance theatrically. It exists in a balanced tension of passive descent and thoughtful ascension, informed by gradients that encourage opportunistic feeding, minimal metabolic waste, and patient interception rather than aggressive territory competition. Most nutrition in the mesopelagic arrives from above. The surface ocean generates organic material constantly: algal blooms, plankton shells, fish molting fragments, reproductive cells, silica flakes, and microscopic carapace debris. When these elements bind with bacteria or organic secretions, they aggregate into clumps. Marine snow. These flakes are not frozen panic, but soft gravity particulate rain that may fall for hours, days, or seasons before settling into deeper pressure columns. But this medium elevator does not fall uniformly. It is lifted occasionally by calm currents, reshaped, swirled, then released downward again in slow procession. This particulate ladder feeds filter feeders at the upper bound of the zone, larvaceans, salps, and opportunistic predators in the mid and lower mesopelagic that read chemical residue rather than scenes. Some organisms choose to rise instead of wait. Zooplankton, including krill, amphipods, and copepods, migrate upward each night because night reduces visual predation risk. This upward drift allows them to graze on surface plankton or smaller zooplankton in short feeding windows. They then descend again before dawn, using inherited circadian timers to metabolize food at depth, exhaling carbon quietly into deeper chemistry. This rhythm is planet-scale consequential, without dramatic bioacoustic splash. Feeding is not governed only by motion, but also by chemical gradients. Vision is expensive here and not always reliable. So many predators evolve chemosensory hunting, reading amino acids or trace nutrients, slowly dissolving in water to detect potential feeding corridors. For example, vampire squids do not sprint to catch prey by speed. They deploy long, limp, neutrally buoyant sensory filaments that trap organic particulate or micro-prey when rising flows pass through their suspended arms. Their feeding strategy is interception, not chase, using faint chemical trail sensing to know when to unfurl their filament nets or graze falling debris. Bristlemouths, among the most numerous fish in this zone by census, do not target dramatic, large prey. Their bodies are pencil-soft, pressure-resistant, tiny enough to be calories efficient and low enough in motion to avoid turbulence signature. They consume microzooplankton or particulate organic residue, drifting into chemical detection maps. Their existence is enormous by population, minimal by metabolic need. ROVs and deep trawls have confirmed that predators here hunt like calibrated sensory nets. Their bodies react only when triggered by nearby vibration or chemical fingerprints. Eyes detect not clarity, but contrast, faint silhouettes against residual blue. Chemosensors detect not scene but residue. Marine life becomes a sensory interpretation, not a scenic observation. Even the ocean's climate systems feed the hunger economy quietly. As vertical migrators metabolize feedings at depth, they transport carbon from surface production into deeper chemistry, where it remains out of short-term atmospheric cycles for decades to millennia. This is part of the biological carbon pump, storing carbon like deep time instead of surface waves. The hunger economy is balanced by energy conservation, tuned senses, gravity-fed particulate ladders, nightly migration, largest migration on Earth, but calm by cadence, and chemical fingerprint sensing that helps predators know where to be without creating territorial aggression drama. Documentaries built on these facts can thus remain calm in delivery without losing scientific consequence. Bioluminescence assists feeding too, but again, never in unpredictable flashing patterns. The angler-like species that drift into this zone from deeper bounds carry faint glow lures. But these lures are biochemical attractors rather than environment illuminators. In the Twilight Sea, information unspools like chemical gradients dissolving into blue. The ocean feeds life softly. Life hunts only when sensing gifts. Defense confuses direction but doesn't declare panic. And hunger is shaped by ancient schedules without dramatic swells. The calculated disappearance of color and the psychology of depth. Color vanishes in the deep long before life does. And this vanishing shapes a habitat that is visually calm, yet biologically abundant. In water, light behaves like a selective eraser, absorbing wavelengths at different rates. Red, the most energetic visible wavelength, disappears in the first 10 meters. Orange and yellow dissolve within roughly 50 to 100 meters, depending on the clarity of the water. Green follows soon after, attenuating into faint suggestion by the time 200 meters is reached. When we enter the mesopelagic, only blue remains. But even blue is not abundant here. It is suggestion level, an ambient minimum light that does not reveal scenery, only silhouettes. This creates a world where the absence of color is part of the environmental psychology. To create documentaries that remain calm, it is important to understand that brightness and chromatic complexity are emotional pacing tools. But the Twilight Zone teaches a different engagement principle: beauty through subtraction, scale through abundance. Curiosity soothed by rhythmic physics instead of overstimulated by rapid scene changes. By evolutionary economy, ornamental pigments become pointless in this depth. A creature's survival does not depend on being seen, but on not being seen, or on being recognized by those who share the same codes. Many animals evolve silver scales because silver reflects the faint blue sideways, dissolving shape outlines into water. Others evolve ultra-black skin to absorb 99% of faint residual light, eliminating silhouette contrast. Some evolve gelatinous semi-transparency, maintaining shape without visual noise. The result is a habitat that, to a human viewer, visually translates into calm blue-black gradients instead of chromatic energy spikes. The most emotionally disruptive light, daylight, fire-toned wavelengths, bright environmental illumination, simply does not reach here. But knowledge travels differently than light, through explanation rather than illumination. This absence of visual urgency affects animal psychology as well. Surface waters reward reactivity, fast turns, escape sprints, rapid schooling compression, flashy mating displays, territorial combat, surface oxygen panic, dramatic predator reveals, sudden depth changes. But the mesopelagic is different. It processes reactivity out of life. Energy is conserved carefully. Motions are efficient. Hunting strategies revolve around interception, not pursuit. Communication is coded, not theatrical. Mating signals are short and spaced. Defense responses confuse direction, but do not oxygen panic. Bodies are pressure compatible and non-air dominant. Metabolisms slow to match feeding corridors that are inconsistent. To adapt evolutionarily here is to let the ecosystem carry you, not chase you. Even bulk water psychology is affected. The deeper ocean is not stirred by storms. The 200-1,000 meter band is not turbulent because turbulence cannot propagate easily downward beyond the wind's reach. This makes the emotional cadence of documentaries here easiest to keep calm because the environment itself does not jolt. The viewer experiences so much less visual aggression that the narration can be softly engaging without overstimulation. Predation is also calmer conceptually than one expects. Sharks rarely inhabit this band, and the predators that do exist are small or interceptive by strategy. dragonfish, hatchetfish, upward-biased tubular eye species, siphonophores reaching occasionally into this band, drifting squids, arrow worms sensing vibration signatures instead of visual fields, amphipods intercepting chemical trails and drifting organic residue, copepods hunting microlarvae of smaller species and releasing bioluminescent confusion clouds for defense instead of escape speed sprints. When a kill happens, it happens quickly and rarely repetitive, leaving no room for dramatic suspense arcs. This environment also hosts the quietest paradox of documentaries, that most fish populations here embody massive scale but small individual presence. The lanternfish schools are so vast that sonar once mistook them as planetary seafloor. But sonar mistakes are not loud emotional discoveries in documentaries. They are conceptual engagements. You can inform calmly while engaging deeply. The absence of color above 1,000 meters is not tragedy. It is narrative clarity, because we focus on contrast, not palette. Engagement is not lost, only redistributed. This zone invites documentaries that feel naturally balanced, calm by gradient, informative by silhouette-based identity, engaging by evolutionary contradiction, that what disappears visually is often most abundant ecologically. Bioluminescence as punctuation. How creatures write identity without crowding the dark. Light in the Twilight Zone behaves thoughtfully, and so does the way organisms deploy it. Bioluminescence here is not loud, rapid, unpredictable burst patterns. It is packetized, coded, short, spaced, minimal, and used for identity, not ambience. If the mesopelagic could be compared to any human system, it would resemble communication protocols rather than showmanship. Depth consumes scenery, but retains consequence, and light becomes the rare message that must be used efficiently. Because of this, most twilight organisms that produce bioluminescence generated in the blue spectral range, the most water-efficient wavelength. Blue light scatters least, penetrates farthest, and does not drag shape into high contrast when attenuated correctly. The lanternfish family remains the most prolific light communicator in this zone. Their bodies are small, pressure-compatible, and lined with photophore patterns that differ by species, like paragraphed paragraphs of glowing dots along bodies. These dots are not decorative, they are identifiers. A myctophid lanternfish may emit a short flash along its flank to identify species to a potential mate, or glow faintly along its belly to match the residual blue arriving from above, eliminating silhouette contrast for predator avoidance. This is camouflage through cooperation, not fear, engaging to learn about but calm to absorb. Dragonfish exist here as well, though many species dwell deeper, some migrating upward into this band at night. The dragonfish carries a long, thin body, motion efficient, skeleton minimal. It often supports a bioluminescent lure dangling from its chin or head, a faint blue glow used to attract prey in a lightless world. But this lure does not illuminate surroundings to spike alarm. It glows sparingly, like a question asked quietly in the dark. Prey that approaches is sensed as presence long before it is sensed as motion. The predator reacts with efficiency, not urgency. The documentary listener learns without being startled by light-pacing spikes. Defense exists through light too, and this is one of the most visually engaging behaviors without emotional disruption. Certain copepods and ostracods, tiny crustaceans drifting through nightly migration corridors, release bioluminescent secretions when disturbed, forming soft glowing clouds. This acts not as terror ink, but directional confusion light that misleads predator strike vectors instead of escalating into faster chase behavior. The cloud blooms softly, then dissolves. Microlight serves consequences without repetition's spike cadence. Comb jellies propel themselves with cilia, tiny hair-like comb plates that sometimes refract faint light or generate microbioluminescent flickers. But again, these flickers are not loud. They shimmer like breath markers in underwater space. Visually engaging, but calm in sequence. Even hatchetfish, small compressed profile predators or prey depending on species, adopt counter-illumination. Their bellies glow faintly with blue wavelengths, matching what little ambient illumination filters from above, hiding them from predators below or allowing them to intercept tiny prey without being silhouetted themselves. Marine bioluminescence in this depth is not a crowd-shouting glow. It is a few sensors flickering IDs across an enormous empty library of water, packets traveling into distance, identity through coding not display, mating through punctuation, not color bouquets, predation through interception, not chase, defense by confusing direction, not inducing panic, and everything spaced by evolutionary arithmetic of rarity. In scripts crafted for Twilight documentaries, viewers remain intrigued without sensory pacing aggression, because light here serves meaning without tempo spikes. Twilight layer design. Biology, written in gradients. This documentary opens not with descent noise, but a quiet statement of immensity. The Twilight Ocean exists as a realm inherited rather than announced, layered between surface clarity and the unlit abyss. Between 200 and 1,000 meters, sunlight weakens into near-complete blue scarcity, not abandoning existence but reshaping possibility. In this interval, billions of organisms participate in cycles ancient enough to predate forests, glaciers, and continental memories, evolving bodies in response to pressure, visibility, and energy budgets that operate without urgency. The ocean writes its biology in gradients, not edges, creating a habitat where evolutionary adaptations emerge in balanced calm, engaging not by shock, but by scale. In the shallow ocean above, fish solve buoyancy with air-filled swim bladders, gas-mediated flotation devices that expand or compress depending on depth. But the mesopelagic rejects gas cavities altogether, because gas does not tolerate 20 to 100 atmospheres of water pressure well. These bladders either shrink evolutionarily or disappear entirely. Instead, organisms adopt bodies suffused with lipids, semi-gelatinous tissues, low-density structural frames, and pressure-compatible internalization of dissolved gases that do not require containment in collapsing sacs. Lipids persist neutrally under pressure. Cartilage replaces rigid bone often, because rigidity is metabolically expensive and structurally unnecessary in a world unseen visually. Protein-minimal skeletons emerge as efficient support frames for animals built not to resist pressure, but to work with it in fluid equilibrium. Biomass density in this zone is unprecedented by terrestrial equivalents. Lanternfish alone may number 1 to 2 trillion globally, though estimates vary because twilight organisms slip between sampling nets, ROV photography windows, and acoustic census boundaries. Even their schools resemble loose congregations rather than surface frenzy, rising each night in vertical rivers and drifting downward again before dawn, restores visual predation advantage to surface hunters. This migration is the largest on Earth by biomass, transporting up to 10 billion tons of animals vertically toward near-surface feeding layers at night. But it creates almost no turbulence signature because individual motion is small and spaced, even within vast aggregations. This paradox informs documentary engagement through knowledge, not sensory density. Light scarcity governs pigmentation psychology. Ornamental colors vanish by evolutionary irrelevance long before light does physically. Red wavelengths vanish in the first 10 meters due to water absorption physics. Orange and yellow dissolve by 50 to 100 meters in typical clear waters, absorbed by particulate matter, dissolved organic compounds, and seawater itself. Green weakens not long thereafter, but blue penetrates deepest, surviving as the world's final visible whisper by roughly 1,000 meters in the clearest open ocean. This leads to three primary palettes in the mesopelagic: mirror silver, ultra-black, and gelatinous translucence. Silver scales reflect scarce ambient blue sideways, dissolving shape rather than outlining silhouette into predation optics. Ultra-black integuments absorb more than 99.5% of all incoming light, eliminating reflectivity and reducing predator-detectable contrast profiles to near zero. Transparency appears within gelatinous species or soft tissue tunicates that simply do not need ornamental pigment. Eyes evolve not for scenic clarity, but silhouette contrast detection. The upward bias of tubular eyes, rod dense retinas, or reflective tapetum-like structures appear because residual light always comes from above. The barrel eye fish evolves cylindrical eyes that view upward through a plasma-clear dome of protective tissue shielding, delicate optical sensors from ultramassive pressure. Its predator strategy is interception, not pursuit, detecting silhouettes against faint residual blue, visually engaging as design curiosity without emotional cadence spikes. The Twilight Zone supports microbial filtration as well. Larvaceans construct mucus houses up to 1 meter wide that trap sinking detritus or micro-zooplankton, filtering marine snow passively. When clogged, they shed these feeding houses calmly downward, creating a continuous particulate rain of organic debris, carbon-bound clusters, micro-shell fragments, and protein chitin aggregates that sink slowly. But this mucus house shedding is not dramatic. It resembles a passive elevator, building then unbuilding structural feeding architecture silently into depth. Predation itself is tuned to scheduling rather than chaos. Many twilight predators use lateral line sensors to detect pressure wakes of migrating crustaceans. Others use chemosensory pits to detect amino acid drift gradients dissolving from above. Arrowworms, amphipods, or drifting squid intercept animals along migration corridors instead of competing violently for territory. The zone processes global climate memory too. The biological carbon pump functions here profoundly, where vertical migrators metabolize surface plankton-derived carbon at depth, exhaling it into deeper ocean layers where it remains sequestered for decades or centuries before re-entering atmospheric cycles via long ocean circulation loops. Oxygen enters this zone not seasonally, but via global density-driven corridors, sinking from polar regions or open ocean subduction points. The result is a habitat protected from surface seasonal panic or turbulence storms. Night movements, false seafloors, and the weight of quiet cycles. This documentary opens again within the ocean's calmest contradiction of motion, that the largest events can unfold invisibly. The mesopelagic is not empty at day. It is energy patient. And it is not chaotic at night. It is biomass migratory with near zero turbulence signature. The largest migration on Earth begins each evening just as surface predators retreat into circadian inactivity. This migration is called the vertical migration. Billions of animals rising and returning daily without sonic splash. Vertically transporting planetary consequence silently into depth. This mass movement may include up to 10 billion tons of animals nightly, including lanternfish, copepods, amphipods, euphausiid krill species temporarily spilling into this band. Catagnaths, drifting salp colonies, semi-translucent tunicate swarms, larval fish from surface species migrating downward into this zone only for transition growth windows, and juvenile squid hovering patiently below surface migration corridors as predators inbound with sensory field arithmetic precision, rather than frantic pursuit. When oceanographers first studied this migration, acoustically using early sonar technologies, 1930s, 1940s, their instruments returned a horizontal reflective layer floating roughly 300–600 meters above the ocean floor. The signal return was too uniform to resemble rocky ridges or chaotic topography. Scientists mistakenly labeled this reflective band as a false bottom or acoustic seafloor. The mistake was corrected only when careful trawl net sampling captured thousands of lanternfish bodies, confirming the cause. Biomass density, not geology. Lanternfish schools were so abundant that their collective reflective bodies formed a living billboard of sonar error. This zone also hosts long-duration passive descents that shape the hunger structure. Marine snow falls from above constantly, comprised of dead plankton, protein lipid clusters, chitin fragments, silica shells, bacterial clusters that bind organic particulate into falling clumps instead of dissolving instantly, and fecal pellet microaggregates that drift downward for hours or weeks, swirling occasionally inside gentle currents that lift them temporarily before releasing them deeper. This particulate rain forms a steady baseline nutrition flow for twilight organisms, feeding filtration creatures like larvaceans quietly, while signaling chemical gradients of amino acid residues that help predators intercept richness corridors without competing violently. Feeding is passive, not panicked. The ocean's sound architecture also differs. In shallow waters, sound waves reflect quickly between the surface and the seabed. But at these depths, the ocean hosts the SOFAR channel, a horizontal acoustic corridor where low-frequency sounds, often from whales, can travel almost 10,000 kilometers without losing intensity quickly. The ocean thus carries communications softly across immense underwater distances. Whales can speak from one side of the basin and be heard on the other, not by shouting but acoustics efficiency. This zone shapes vision chemistry as well. Many animals evolve tubular, upward-biased eyes tuned to detect residual blue light contrast from above rather than scenic clarity. Photoreceptor rods dominate retinas for faint photon capture efficiency. Since visibility is low, surface pigments vanish by evolutionary irrelevance. Most animals are mirror silver, translucent, or ultra-black, palettes that serve silhouette dissolution instead of identity display. Predators do exist here, but the chase does not. Dragonfish territories extend occasionally into the mesopelagic at night as predators intercept vertical migration corridors using faint blue glow lures, not sharp light flashes. Hatchetfish glow faint bellies to dissolve silhouettes for predator avoidance or to intercept minimal prey. Vampire squid unfurl long sensory filaments to capture micro-prey or organic debris when sensing gradient richness rather than sprinting aggressively. The zone interacts with climate memory through carbon flux movement too. Vertical migrators transport surface-derived carbon into deeper ocean storage by digestion and metabolism. This removes carbon quietly from short-term atmospheric cycles, assisting Earth's long-value climate buffering without drama spikes. Daily migrations, sonar billboard paradoxes, unhurried particulate feeding ladders, pressure-compatible soft tissue design, upward-biased contrast, eyes detection, vast acoustic highway conduction, minimal color palette silhouettes, chemically encoded hunger maps, enormous consequence through replication rather than emotional cadence spikes, defines the mesopelagic in ways that remain restful while conceptually engaging. The long breath of the middle deep. Why the Twilight Zone changed documentary storytelling forever. This final part of the documentary begins with a truth that is calm in tone, but seismic in meaning. The mesopelagic Twilight Zone is not a footnote world. It is one of the most globally consequential habitats, where light fades, but life continues with quiet power. The purpose of this documentary is not to thrill the senses, but to inform the mind gently, building engagement out of wonder, contradiction, science, and planetary scale, all delivered with a composure that mirrors the zone itself. A depth interval shaped by soft physics and patient biology. This introduction is not suspense. It is invitation, the beginning of an understanding. The Twilight Zone altered storytelling not because it is dramatic in behavior, but because it contradicts intuition. It is both the most crowded habitat by biomass and the least crowded habitat by audible turbulence. Sonar instruments, the quietest and most respectful method of deep ocean discovery, revealed the first clues. When early oceanographers sent sound pulses downward, the readings returned unexpected reflective bands that appeared to form a horizontal floor far above the actual seabed. This curious reflective band became known as the deep scattering layer. It was mistaken for geology, not because it moved too violently, but because it moved too uniformly. An undramatic acoustic return that resembled a flat plane. Later, sampling nets revealed the cause to be life, not rock. Lanternfish and zooplankton clouds formed this reflective band. Billions of bodies rising and falling slowly enough that turbulence did not reveal them. But depth instruments did. This discovery changed documentaries forever because filmmakers realized that engagement does not have to be loud, and that the most impactful stories are sometimes the ones least dramatized. The mesopelagic is also Earth's most important daily carbon transport stage. Creatures here perform the largest migration on Earth, known as BDL vertical migration, where trillions of organisms ascend toward the surface each night to feed, then return downward before dawn. This migration is not frantic. The vertical motion of lanternfish creates minimal pressure disturbance. Each fish only a few centimeters long, each motion dissipating into surrounding water almost instantly. Yet, by numbers, they move 10 billion metric tons of biomass nightly. This migration moves carbon as well. Organisms eat carbon-rich plankton above, then metabolize at depth, releasing carbon dioxide and ammonia into deeper ocean layers. This removes carbon from rapid re-entry into the atmosphere. It joins deep currents, traveling through planetary circulation for decades, centuries, or millennia before resurfacing. The Twilight Zone is thus a manuscript corridor transporting climate consequence not by conquest, but digestion. Documentary storytelling learned to imitate that rhythm, consequential without chaos. Predation, too, became a lesson in calm efficiency. Many fish here do not chase prey rapidly. Chases waste energy, and energy is precious in cold metabolisms. Instead, predators are built for interception biologically and chemically. Dragonfish drift with faint blue lures that glow like a quiet question rather than a bright alert. Hatchetfish glow their bellies with counter-illumination matched to overhead minimal moon-shifted blue, dissolving their silhouettes into the ocean. Squid hunt by extending long, ribbon-like sensory filaments that wait for prey vibrations or particles to drift into detection. Copepods sometimes release short luminescent confusion clouds to misguide predator strikes without inducing fear-based pursuit escalation. The predators of the zone hunt like librarians, scanning quietly for misfiled pages instead of warriors sprinting into battle. Documentaries adopted this philosophy, engaging by information architecture rather than emotional spikes. The psychological calm of this zone is also protected by depth physics. Storms that churn into surface waters almost never propagate downward beyond 100 meters as turbulence. In the twilight layer, there are no hurricanes, no loud currents, no seasonal temperature drama, no oxygen pressure expansions or collapsing gas pockets within most bodies, because meson gas pockets are evolutionarily minimized or removed. This creates a depth that is stable by physics, not emotion. The filmmaker's lens adapts here too, because the most calming visuals arise from depth's natural aesthetic. Gentle blue-black gradients, slow particle descents, faint bioluminescence punctuation that identifies species instead of flashing alerts, and a sound landscape governed by low-frequency harmonic conduction through the SOFAR channel instead of echo ricochets. Engagement is thus cognitive, not frantic. Most of the animals here also possess micro-metabolic budgets. Lanternfishes, bristlemouths, copepods, amphipods, larvaceans, salps, jellies, and squid larvae live in a slow negotiation with cold, ranging typically from 4 to 8 degrees across most oceans. Their energy demand is so small individually that being an abundance is possible without crowd noise. Some species live decades or centuries here, but reproduction is network-coded rather than rapid. Bodies glow only briefly for identity confirmation or mating punctuation. Many fish do not even need dramatic skeletal muscle. Neutral buoyancy via lipid deposition suffices. They drift as though approved by the ocean's scarcity economy, rather than reacting urgently to it. The documentary tone mirrors this presence. The Twilight Zone also taught science how to sample respectfully without dramatizing. Modern deep-sea discovery uses ROVs, controlled sonar imaging, submersible sampling, plankton nets, pressure temp sensors calibrated slowly, DNA trace detection, environmental particulate capture, and faint blue illuminators instead of chaotic spotlights. The ocean is not ransacked, it is interviewed quietly. Documentaries that follow this niche speak like narrators reading collected field notes instead of shouting discoveries into the void. The environment itself ensures calmer emotional pacing. Acoustics also reward calm. In this zone, the SOFAR channel traps sound horizontally, allowing low-frequency signals to travel extremely far with minimal dissipation. Whale song, one of nature's slowest melodic communications, can move thousands of kilometers with no sharp echo returns, sounding farther, deeper, older, calm, and persistent. Some squid generate minute clicks, some fish make faint pressure pops, but communication is rarely in sharp or irregular tempo. The ocean is information-rich and noise-poor. It is a place to be sensed, not sounded out into fear. Documentary scripts adopt a voice cadence that respects overlapping acoustic bandwidths through smoother transitions. What makes the mesopelagic zone ideal for content designed to balance calm plus learning is not a lack of the strange. It is a lack of the sudden. Strange appears, but attenuated. Pressure is immense, but incremental. Light fades, but smoothly. Predator strikes happen, but rarely repetitive. Schools gather, but silently. Marine snow falls, but gently. Carbon moves, but like time, not shock. Vision is tuned to contrast suggestion, not scenic spikes. Migration is timetable, not terror. Chemistry dissolves into gradients that are sensed without frenzy. Acoustic channels conduct sound without rebound chaos. Water molecules cycle thermohaline American distances, traveling for centuries or longer before resurfacing. Life moves in the largest numbers, but the smallest motions. Ecosystems feed via gravity inheritance instead of violent upwelling collisions. The ocean holds calm as default, consequence as background story, not a sensory spike soundtrack. This is why the Twilight Zone redefined engagement as knowledge-driven storytelling, not intensity-driven spectacle. For your faceless channel, this means the zone's most natural translation into media. Visuals can hold the deep blue gradient, slow motion drift, and particle fall. Narration can be engaging but not overstimulating. Music or ambience can be low and persistent without tempo disruption. Storytelling is conceptual rather than suspense-based. Engagement arises from scale and design, not shock. Viewers are informed without being startled. The brain learns softly while the body remains in calm reception. Calm can be the baseline mood, while information becomes the gentle shape moving through it. The ocean's own contradiction becomes the hook. This zone does not beg for attention. It quietly earns it through scale, adaptation, acoustics efficiency, particulate feeding manuscripts, and evolutionary designs that work with pressure rather than resisting it aggressively. Documentaries now adopted longer fades, slower dissolves, deeper color economy, tubular, upward-biased sensing, rather than visual resolution overload, bioluminescent ID punctuation instead of flashy orchestration, intercepted feeding economy instead of chase music, rhythm ladder migration explanation arcs instead of predator reveals, and manuscript learning tone instead of host presence. You remain faceless. The ocean supplies the face of the story. And although calm is the listening mood, learning becomes the undertone, not the spike. Blue nomads and invisible navigation, movement as a quiet compass. This documentary opens on movement itself, but not the kind of movement that disrupts. In the twilight layers of the ocean, locomotion becomes a quiet compass, a biological decision shaped by physics that does not scream direction, but holds it steadily. Here, between 200 and 1,000 meters, animals migrate vertically through a world defined not by landmarks, but by inherited pressure gradients, faint light references, magnetic suggestion, temperature corridors, and currents that guide motion rather than interrupt it. The ocean becomes a guide without tempo, and life moves like a calibrated visitor. Lanternfish again are the zone's most reliable nomads. Their bodies are engineered for travel without fatigue. Lightweight skeletal designs minimize motion drag. Lipid-rich tissues act as internal buoyancy stabilizers under pressure without collapse. Their migration is driven by circadian cues. Each evening, their bodies detect diminishing light at the surface. When moon-enabled night arrives, they rise toward food in short windows. Long before dawn, they drift back downward. Despite billions moving in unison, water pressure wakes remain minimal. That is why this migration does not create storm-like turbulence. Zooplankton accompanies them as a drifting protein constellation. Copepods, amphipods, euphosids, salps, and larvacean larvae rely on an inherited biological clockwork, rising thousands of times their body length upward each night, then returning again with no splash footprint. Many squids here also drift, not sprinting forward, but rising vertically through conserved jet-like siphon pulses that are rarely repetitive by nature. The jet propulsion of squid funnels, common deeper in the ocean, appears here thoughtfully, quick when used, rare by metabolic economy, quiet in sound signature. Their migration pace is slow, efficient, rarely erratic. Animals navigate not by maps, but by environmental signatures. Some species read faint magnetic cues. The ocean subtly interacts with Earth's magnetosphere, a weak but directional reference field that some migratory animals detect for orientation. Though this zone does not host complex magnetic brains like birds above, traces of magnetoreception have been suggested in certain migratory species for directional equilibrium in open ocean intervals. More important than magnetism is water density reference. Ocean layers differ chemically, thermally, and pressure density-wise. These density interfaces form migration highways that are not collisions, but transitions. Animals lean into these boundaries for navigation guidance. Sound is directional but calm here too. The SOFAR channel helps external songs travel, but species in the twilight band rarely need long acoustic messaging. Their communications are local, filament-based, pressure wave-based, or chemically sensed via gradient, rather than auditory signals that echo. Navigation is primarily tactile by lateral lines and chemical by gradient reading. Jelly drifters detect pressure impulses from approaching motion. Fish detect hydrodynamic signatures from migrating schools. Squid chemosensors read amino acid drift plumes. Hunger maps guide direction without speed chaos. The deep is also a birthplace for camouflage migration psychology. Hatchetfish and pearl sides adopt counter-illumination, signaling identity or camouflage through faint belly glow that matches ambient blue from above rather than shining unpredictably. When these fish or squid migrate at night, they do so more safely because their silhouettes dissolve into the faint background. Navigation includes invisibility too, camouflage that supports detection-free travel, not speed bursts. Human viewers learn that existence here does not need frantic landmarks. The ocean itself provides highways, currents moving by pressure gradients, density corridors inherited thermally, feeding escalators rising nightly without world chaos. Buoyancy answered by lipids, not gas cavities. Sound carried without echo overlap confusion. Vision tuned only to contrast, not clarity. Migration guided like slow-breathing, time-ladder pulses. Even the ocean's microbes recognize schedules too. Bacteria that bind sinking organics do not spike reproductive audio drama. They bind residues into clusters that fall consistently instead of dissolving instantly. This creates a calm nutrient ladder for drifters to intercept gradually. Marine bacteria do not hunt. They consume. They do not travel rapidly. They inherit depth through interface-bound particle descent, driven by gravity and pressure equilibrium. Their biomass signature is invisible, but atmospheric by consequence. This zone teaches a new form of documentary engagement grammar. Motion that informs scale without turbulence, noise, biological clocks guiding direction that don't spark alarm reactions. Camouflage navigation that supports detection-free travel without speed chaos. Deep currents carrying messages without echo overlap. Pacing aggression, density corridors providing graphics of guidance, not collisions. The viewer learns that in the Twilight Zone, movement is a compass, but calm is baseline. Navigation is inherited sensor tuning, not scene geography. Light fades but does not intimidate. Biomass corridors feed direction without chaos. Pressure answers bodies softly, allowing the story to drift like slow blue handwriting in motion. The planet's largest middle layer, climate, consequence, and calm reception. This documentary opens on the most important truth about the Twilight Zone that is rarely spoken with cinematic awareness. It is one of Earth's greatest climate engines, regulating carbon, oxygen, nitrogen, and heat memory through biology rather than turbulence. The mesopelagic is a planetary bridge, not between landmasses, but between atmospheric cycles and deep water sequestered chemistry. What lives here shapes the environment longer than the environment shapes emotion. This is an engagement not of fear, but importance. The giant biological carbon pump functions through digestion and vertical migration arithmetic. Creatures feed at shallower illuminated zones, then metabolize deeper in the ocean. Instead of exhaling carbon into the air immediately, like land mammals, twilight migrators process carbon underwater, dissolving CO2 slowly into deep ocean chemistry. There it can remain diverted from short-term atmospheric cycles for decades, centuries, or millennia depending on circulation corridors. The ocean is the largest carbon reservoir on Earth, holding over 50 times more carbon than the atmosphere. The biological pump here contributes substantially by carrying surface-produced carbon downward. Through repeat migration arithmetic, not sudden upwelling collisions. Each night, up to 10 billion tons of life ascends not to warm the ocean, but to eat, then sinks again to digest, distributing carbon into depth with quiet chemical consequence. It is the planet's most enormous respiratory rhythm, happening not with splash soundtracks, but biophysics timetabling. The oxygen story is equally calm in cadence, but huge in consequence. The Twilight Zone still contains oxygen, but not always uniformly. Oxygen enters these depths primarily through polar subduction, regions where cold, oxygen-rich surface water sinks due to density, especially in the Southern Ocean around Antarctica, or in saline-dense northern regions of the Atlantic. This oxygen is carried by slow, deep currents instead of fast, warm, upwelling systems. The mesopelagic steals nothing from calm reception because water sinking does so smoothly, carrying oxygen into layers that visually look empty, but remain respiratory consequential, hosting animals that metabolize slower due to cold, conserving oxygen via low movement and rare communication instead of rapid territorial chase. Some species even avoid disclosing themselves acoustically in ways that may startle the viewer. The documentaries can explain oxygen contrast without implying scarcity panic. This zone also processes nitrogen cycling. The ocean contains dissolved nitrogen compounds, ammonia, nitrate, nitrite, processed by migration animal metabolisms and microbial binding reactions that quietly fix nitrogen for slow chemical exchanges, sustaining twilight food ladders without dramatic seasonal plume spikes. Documentaries should express these cycles in calm reception, because the environment's shifts are molecular, diffused, non-fracture based, and quiet in sequence. Trophic zones exist, but with calm spacing. Filter feeders trap organic detritus without racing. Predators intercept outputs of migration corridors instead of chasing constantly. Bioluminescent flashes are coded, not repetitively blinking suspensefully. Life exists in tiny capsules, immense by number but small by motion, forming minimal turbidity plumes unless disturbed by ROVs or nets temporarily sampling them respectfully for science rather than showmanship. Currents at this depth are thermal memory translators, not seasonal agitators. Thermodynamic heat exchange happens slower. When surface waters warm near the equator, they rarely send that warmth below 200 meters effectively as direct metabolic fuel. but deep currents disperse warmth globally, like a long-term time-average heat distribution, rather than sudden interactions. This allows documentaries to speak informatively while keeping a visually calm palette. This is also one of the most unclaimed territories on Earth, not by political decision, but physical impossibility of visual intrusion. Humans interview this zone through ROVs, controlled sonar pulses, submersible light capture that is localized, not floodlit. Sample nets drifting downward like slow mechanical arms capturing biological samples, always spaced, attenuation-based, respectful by calibration instead of conquest. Therefore, for a faceless, sleep-friendly documentary channel, the environment itself provides calm by pacing. Light does not announce spikes, color does not overstimulate. Predators do not chase storytelling adrenaline arcs. Biomass rises nightly, but individually moves only centimeters per second. Marine snow falls passively, not uniformly. Pressure increases mathematically, not unpredictably. Acoustic highway conduction respects overlapping bandwidths silently, without echo collision overlap. Nitrogen and carbon cycles dissolve into gradients rather than theatrical plumes. This zone is proof that knowledge is more dramatic than scenery when delivered thoughtfully. Calm is more impactful than excitement when cadence is minimized. Allowing documentaries to engage while remaining emotionally stable, informative while remaining soothing, and slow without being silent. In this final chunk, the viewer learns that the Twilight Zone holds Earth's climate consequence quietly. A massive system operating without panic, mathematics over drama, digest over chase, coding over announcement. Leaving documentaries to imitate that cadence. Calm reception first, awe-infused information second, conclusion without cliffhanger. The deep sea is not a world that rushes toward answers. It is a world that lets answers sink into us slowly, like light turning into blue, blue turning into distance, distance turning into curiosity, without urgency. In tonight's exploration through the Twilight Zone, we drifted alongside organisms that live suspended between brightness and the true abyss. Creatures shaped by pressure that does not collapse them, migration that does not panic them, and light that communicates without flooding the dark. This ecosystem carries immense consequence quietly, proving that scale does not require chaos and discovery does not require a face to narrate it. If this journey leaves you with one lasting impression, let it be this: the planet's most mysterious worlds are often the calmest teachers when we allow ourselves to simply listen and observe thoughtfully. More than 70% of Earth's surface is ocean, and most of that ocean remains unseen by human eyes. Not because it is empty, but because it does not reveal itself all at once. The Twilight Zone, hidden but alive, continues its daily cycles far below storm and season, carrying biomass and carbon through planetary circulation like a climate manuscript written not in noise, but in motion. Each night, trillions rise, feed, digest, and return, participating in Earth's oldest rhythm without audience, yet full of meaning when observed through science. The ocean does not need us to make it important. It simply is important, quietly so, and endlessly so. As we close this documentary, the water column remains long, dark, ancient, and unbothered, and life continues its migrations somewhere beyond the reach of bright lights and loud timelines, carrying out processes that regulate climate memory, biological endurance, and evolutionary grammar. The deep has no final page, only deeper pages. There are no goodbyes here, only pauses between dives. Until the next exploration, the ocean will keep breathing its slow stories into the blue dark, and we will return to translate them with the same balance, engaged by wonder, soothed by cadence, informed by truth, and faceless by intention. Because some stories are better told by the world itself, not the narrator.